thanks for coming tonight. Yeah, it looks like I'm singing tonight, but it doesn't. It doesn't. So don't worry. So I'm not singing very well. But anyway, so welcome to the session tonight, which is about getting started with Azure AI Studio. So for over next half an hour or 1.5 hour whatsoever. So we are introducing the how to use Azure AI Studio, and followed by my colleagues, Richard, will be discussing about Azure Cosmos DB. Okay, and if time allows, I'm going to show another demo about the how we can load balance the Azure AI OpenAI SDK. All right, so let's get started. Yeah, let me introduce myself. I'm Justin from Microsoft as a principal cloud advocate. And yeah, so as I said, we are talking about Azure AI Studio tonight. So I'm pretty sure that you have probably seen this picture before. So this is our end-to-end, the Copilot stack for every single organization that spans their infrastructure, the foundation models, data, tool chains, and of course the Copilot itself. So today I'm going to build from the bottom to the top. All right. So I'm going to talk a little bit about the foundation models we as Microsoft provide, and the orchestration engine we have, and the AI toolchain that we provide, and how we integrate with data sources. And the tooling we use for that is Azure AI Studio. We will see soon. So are you ready to see that? Okay, yes, let's do it. So Azure AI Studio is now currently in public preview. But I really highly recommend you to visit the ai.azure.com and give it a try. And I think I'm in Nashtech here, and I think you have the access to the OpenAI anyway. So we have brought all of those practices together from the Copilot stack. So all the knowledge that we have gained is from the building and operating our Copilots at scale. Actually, we applied all the Copilots to every single product and services from Microsoft anyway. So with the Azure AI Studio, so we are unifying the multiple different AI services into one experience. So it incorporates Microsoft data and such technologies, several foundation models in a safe and responsible way. So it brings a full end-to-end development lifecycle that supports emerging trends like LLM Ops for managing lifecycle and versioning of AI systems. So let me introduce AI Studio first. All right. So this is the AI Studio. So when you visit to ai.azure.com and log into the AI Studio, you will be able to see this screen first. Then I created AI project first. So if you want to, then you can create new AI project. And so I create this one. So AI project Hanoi 0410. And these are the dashboard, overview dashboard. And I will show you how the project settings look like. So this is the AI project settings. We have the configurations. We use AI Hub as a resource. It shows the Azure subscription that belongs to that's the resource group that the virtual machines and all other computing resources behind. And also we use the OpenAI AI region we are going to use. And this is the permissions. I mean, this is the section who is eligible to access this project. So we can granular the control for who can access, who cannot access, or something like that. And also these are the endpoint API keys for how to use our API as an API. I'm show you how to integrate existing open source the LLM models into our AI Studio, so that the model as a service. So I will show you later. And also these are all the connections that we are going to use within this AI project, like OpenAI and cognitive search, and blob storage, and so on. Also, these are all the computing machines that behind the scene. So these are all like the virtual machines for like indexing or something like that. And what else? What else? So yeah, so these are all the things, and this is the prompt flow I'm going to introduce later on. So these are the basic settings of the AI Studio project. So if you are joining the AI Studio, and if you want to run your own AI project, then the first thing is create the AI project. Then these kind of things will be happening behind the scene. So let's move on to the playground. So here I'm going to play around a few things here. So let's say, so this is I think you probably here see that. So AI Studio is a collection of all the AI services like OpenAI Studio, Machine Learning Studio, Language Studio, Speech, Vision, Translator, and so on, right? So these are all the collection of AI Studio, the AI services. Here, this is the playground, and we are using the chat thing, so which is similar to the basically ChatGPT, and I'm going to use the GPT 3.5 Turbo, the model. Here, let's say, tell me about the city of Hanoi, Vietnam. Then it will return very generic message, right? So this is the old Hanoi generic message of Hanoi, which is already trained within the large language model. And then let's change, because that returns or because of this system message. So it says you are an AI assistant that help people find the information. So this is very generic, right? So if I change this value, this system message into something different, like this. So you are an AI assistant, and you always respond in a rhyme, and you are friendly and funny, which means if I change this system message like this, then it will return the same response in a different way. So let's take a look. So it applies, and I will change another one. Then let's do this again. Tell me about the city of Hanoi, Vietnam. Then the response might be different, right? See this? So it sounds like a singing, or it generates the response as like a poem, right? Because I changed the system message with a rhyme, right? So it rhymes. So yeah, so that's how we can play around our AI Studio with different the style. So basically, that system message determines the way of responding, the generating the response based on your prompt. Okay, so this is the how we do the AI the studio. So yeah, that's the end of the thing. And also let's change a little bit different. So I will use a different the style in the next time. So let's get back to the different the one. So I've just shown you introduction how Azure AI Studio looks like, right? And its capabilities. There are much more things that will be coming up soon. So let's talk about data. So you probably heard this quote, like data is a fuel that powers AI. Or you have heard something like garbage in and garbage out. So what does that really mean? So if you don't feed a good data in your LLM, then you're going to get a bad result, right? So when I talk with customers, one of the most common questions or common issues I receive is that the data quality is not well formatted. So if data is not clean, if the chunking of the data is not right, and the embedding is not right, then you will just get a bad result. right? So when you train models, it is really, really important to have the right chunked and embedded data, right? So we at Microsoft are focused on the simplifying those processes, like the generating the quality data set, right? And process of connecting to the data and formatting it correctly. Also, Azure AI Studio offers the connectors to all Azure data sources for easy integration, such as like Azure Blob Storage or Azure Data Lake, Fabric, even local files or folders, and even third-party external cloud service providers like AWS or Google whatsoever. And Azure AI Studio can handle both structured and unstructured data to feed models. So the ultimate goal of feeding those data is that to ensure the models receive the necessary information to generate the optimal result. And at the heart of all of this is the concept of vector search and using the vectors for data representation. So I'm not good at the math, so I cannot explain more about the vectors, something like that. So, but all I can say is vectors are mathematical representation that allows systems to easily compare the data for the relevance and similarity. But it turns out, sometimes not all the vectors are created the same, okay? So they can vary in their creation and quality. So you can see that Azure AI Search. So this is a new rebranded name from the Azure Cognitive Search. So it supports vectors. So because it doesn't just bring together all the vectors, it actually brings together vectors with the semantic search and classical keyword and the keyword search as well. So let's take a look at this the graph. So I just talked about the vector search, right? So and actually using this vector search, it has a dramatic the improvement of the result, and you are likely to get out of the search index. So Azure AI Studio offers 3 different the type of search options. One is vector search, and the other one is keyword search, and the third one is hybrid search. So vector search is actually what I have told you before. Like it improves the understanding, the user intents, and relationships between the words. But it's also at the same time it struggles with like exact matches. But keyword search, on the other hand, is very good for like finding specific terms, specific items, like a product document, email address, or phone numbers, something like that, and it's even faster. But hybrid search is like I'm picking up the benefits of using both, right? It's a combination of both the vector search and keyword search, right? And in order to cater the user needs and leveraging the strengths of both. And the top one is the vector search plus semantic search. So that builds upon the other two and incorporate the semantic ranker model to prioritize the most relevant information. So without the Azure AI search, I think we can implement all the vector search, the keyword search, and both the hybrid search way. But with this Azure Cognitive Service or as Azure AI search, we can do another one like a hybrid plus semantic search. So this is the thing we can use. So what does that mean? Is that I just showed you the AI Studio with the generic, like the prompt, the skills. But there are many use cases. There are many use cases that we need to use our own company data. Let's think about we are selling the outdoor, the goods and services, right? And we want to put some our product catalog information into there. But the base foundation model doesn't know what those kind of data is, right? So in this case, how can we handle these kind of things? So let's put another one. So this is something And I'm going to add, where is it? So I'm going to add a question, something like this. So let's think about we are at the auto company. So we are in auto company. So I want to find out the information like this. How much is the trail worker shoes? Then it says, okay, I'm sorry, I have no idea, because the trail worker, the cost of the trail worker is very specific to our business, right? And I use generic the GPT 3.5 Turbo, which means it uses generic the information. So I can ask that model to like, what's the tell me about the city of Hanoi. It answers that, but it doesn't. It's not able to answer these kind of questions. How much is the shoes, something like that. So how can we improve this the result? In here, we can add our own data. So I have already put the index data here. So let's say we have the product index here, and there is a search types. So as I said, we have semantic search, we have a keyword search, we have vector search, and as a default is the hybrid search, vector plus the keyword search. But I'm going to use a semantic search here. Then I will ask the same question again. How much is a trail worker hiking shoes cost? Then let's say it says, okay, it's $110, right? Because I put the index data, which means it has all the information of our product catalog, right? And the good thing is, if I change the question in a different way, say, I'm not sure this is correct translation in Vietnamese. So is that correct Vietnamese translation? So if I ask that, then it returns same result. But I asked the question in Vietnamese and it answered the question in Vietnamese. That means the large language model understands the context, right? So if I ask the same question again in different language, like Korean. So if I ask the same question in Korean, like how much is the trail worker? Then it might return in Korean, hopefully. Yay. So it returns in Korean because it understands the context of the asking questions, right? So this is how we can add our own data set into the foundation model. This is called RAG pattern, which stands for retrieval augmented generation. Okay, and here I think there's a problem. There's a potential issue if we add our own data set here, because we have no idea our data set is like a properly indexed or not. Okay. In this case, how can we make sure our data set is correct or our data set is safe from the abused search, something like that. So if we have some sort of data set, we have no idea, but there is some sort of misleading information or potentially harmful information or something like that. How can we make sure we all filtered out these kind of things? So in this case, we can use evaluation, right? So I'm going to use this evaluation. Oops, not this one. So manual evaluation, I'm going to create manual evaluation like this and use the same thing. And my data is using the same product index and use the semantic the hybrid semantic search, and I can change it to the GPT 3.5 to GPT 4, but for now I'm going to use just like that as a default option. Then I will put the same question about this. How much is the trail worker cost? Then I will be expecting $110. Okay. Then run this the evaluation, and if it returns $110, then this model is okay. Okay. So this is how we do evaluation, and we are just running the one question. So if it returns correctly, I can just thumb up. Then the data is rated 100% okay. So we have some sort of expectation. At least 70% is getting the thumb up. Then we will accept this data set as a for evaluation. But if it's lower than 70% or something like that, then our data set is not really ready for our RAG pattern or something like that. So in this case here, so I will use the existing data set. It has the bulk, the question data set here. So I'm going to use this. And it has like, how many questions? It has 10 questions. So that's the question, and that will be expected answer, right? And edit. So these are all the question, pre-loaded question data set. So if I want to run in bulk like this, then these are all the expected response. And if those outputs are expected, then I can say thumb up and something like this. So, okay, outdoor living, okay, outdoor living, okay, okay. And here, what is the floor area to the floor area? And we are expecting 80 square, but it says, 120. So that means our data set is not ready for this specific question. So I can say thumb down, something like that. So based on that, we have pre-loaded 10 questions, and we have, I just thumb down one question, I thumb up 2 questions. So I keep doing like that. And if our data rated over a certain range that within the expectation, then our data set is correct. And these questions can be something like sexually abused the information, or something like a jailbreak information, something like that. So if we can avoid this kind of our data set, then the RAG data will be ready, right? So this is how we can use our own data set. Okay, so let's get back to the demo again. Now, see, one of the core things that we are going to determine if the Copilot is successful or not is the foundation model you built on top of, right? So I have shown you about the importance of data set, but at the same time, if you choose the right foundation model, and that's also on an important things, right? So in Azure AI Studio, we have models from OpenAI, such as like a GPT-4, or GPT 3.5, GPT-4 Turbo, and so on. But also we have a model catalog that bring in the open source large language model as well, such as like the Mistral, or the Meta's Llama, or something like that. So the purpose of bringing in those open source the large language model is for us is to make sure that customers have their choices, right? Because one size does not fit all. Something, for example, GPT-4 is really great, but it's at the same time it's a little bit slower and more expensive, right? In this case, companies may have like a cost optimization issue. In that case, how do we really need GPT-4 for our specific needs? Then probably we might need to find out the other option, something like that, right? So sometimes you need a specific model. Sometimes you need the other models, or sometimes you need the combination of the both or multiple the models, and you can get the right result. So most of Copilot at Microsoft actually uses the mixture of different models to get the right result. So recently we have announced the availability of GPT-4 Turbo and GPT-4 Turbo with Vision and DALL-E 3 into the Azure OpenAI service. So GPT-4 Turbo offers the same accuracy as GPT-4, but with increased the efficiency and higher throughput. This enables us to reduce the price, right? and the token-based, making applications that the more accessible and enabling new scenarios. These are things. The large language model is charged by tokens, and that tokens actually based on the Latin language. So like the Eastern language, like Vietnamese, Korean, or Chinese or Japanese, they spend more tokens. So we are a little bit in the unfair world, but that's how it is. Also, DALL-E 3 provides a substantial improvement in an image creation quality over DALL-E 2. But I want to spend a moment here and talk about the multimodality. So traditionally, the large language model is only based on text, right? But multimodal models go further than that, okay? The multimodal models go beyond the text. It generates video and images. Also, it takes in videos and images and analyze those the images and videos and to generate the response. And so you can use this GPT-4 Turbo with Vision to enable the multimodality. I will show you a demo later. And also about the data security. I think the most people here are very interested in the data security here. So a lot of questions I get from the customers have to do with what happens with their data in our Azure AI Studio. So the questions like, they always ask me like that. So do you use it to train your foundation model? No. Is it secure? Yes. How are you using it? We don't use it. We just store your data into your subscription. That's all I can say. So basically, your data is your data, right? Customer data is storing within their subscription, and that's not going outside their subscription. Okay. So so when you fine tune the model, then the Azure OpenAI service or something like that, the weight of the fine tuned model stay in their subscription. So, and from Microsoft, we are not able to see them because they are already encrypted at rest. Okay, so those kind of data is kept secure in their subscription in the same region. So reflecting, the Azure's commitment to data security. So if you are like selling the Azure AI Studio or OpenAI model to your customers, or even using within your organization, yeah, don't worry about that. So, and this is one of the most commitment stuff. Another announcement we made a few months ago, and I want to make sure, is that you can find, before that we were not able to fine tune GPT 3.5 and GPT-4, but now we can fine tune GPT 3.5 and GPT-4. And I just told you about fine tuning, and before that I showed you about the RAG pattern, right? So actually, these two things, the demo I show you was all about the RAG pattern, right? But the RAG is great because it's efficient and cost saving. So you don't have to change all your foundation model. You just add your own data on top of the foundation model. But on the other hand, fine tuning requires additional computing resource to adjust the model's weight, right? So is that the one interesting thing is that the fine tuning is that sometimes fine tuning is not the best way of the modeling for these kind of things, but it's good for like the changing the weight and like changing the format of outputs or something like that. So these two technologies, like RAG and fine tune, these are competing each other. These are not competing each other. I mean, so you can choose both. It's not something like choose one thing over the other, right? So you can use both at the same time. And also, Azure AI Studio, within the Azure AI Studio, we offer both technologies. So you can, you can use both. Yeah. Then I want to emphasize this one as well. So as I said, we use OpenAI models like a GPT stuff. But as I said, we also introduced or brought into our AI studio with the open source models like the Llama or Mistral or like the Cohort, Cohere or something like that, right? So these are things but at the same time, we have no idea which one is better than the other at the same time. So we need to make sure we need to be able to compare which model compared to each other of our choice, right? So that we can get the better result. And also, based on those catalog, and we can deploy or fine tune those models into our infrastructure. Okay. And how does it work? We use models as a service. We can say MaaS, right? Okay? Model as a service. So when we go into the Azure AI Studio, there is a bunch of the catalogs here, there. So we can choose some sort of models and compare to each other. And then based on the results, then, okay, so I will choose this model, then deploy it or fine tune it, something like this. So, and at the same time, there are a bunch of different benchmark results, right? So one benchmark result says, oh, this model is better. And the other benchmark result says, oh, the other model is better. So we have no idea which one we need to trust, right? So in that case, Azure AI Studio prepares, so is ready to for you to use. Bring your own data set for benchmarking. So based on the benchmarking result, you can choose which model is better for the specific needs, right? So this is something I can talk about the benchmarking stuff. So let's go into the demo again. Oops. So where is yeah, here we go. So these are in the AI Studio, and when you go into the Explorer, so there's the tabs, catalog and benchmarks. So if I click the benchmark tab here, then oops, and here where is my catalog? Where is my benchmark here? Okay, so this is a benchmark, and choose a task which one I'm going to compare. So let's say question and answer. And there are a bunch of the models already in our catalog here. Let's say Llama 2 70B and Llama 2 7B here. So I choose that and compare models, something like this. Then it says, okay, these are the accuracies and these are coherence, and this is the visualization of the benchmarking result. But this time, this is like I'm using the generic the data set. So I don't think it correctly represents some sort of benchmarking result for your specific needs. So we are slowly bringing up capability to use your own data set. So once it's ready, and you will be really able to benchmark the differences between all the models here. And also another one is model catalog here. Let's say, okay, I'm going to use Metas and Llama or or Hugging Face or something like that. And there are a bunch of the models here. So let's say I'm going to use Llama 2 7B model. Then this is the one, and here this is the options we can choose, either deploy or fine tune. So let's say deploy model. That means we are deploy this Llama model into our subscription. Then after we deploy this model, we can just simply send the API request to use that. This is very useful for the companies who don't want to maintain their infrastructure for this one, right? So that's why what they can do is that they just send an API request and get the result from that API response as a response, right? So by doing so, they don't have to maintain all the infrastructure to maintaining those models by themselves. But my subscription is not allowed to deploy this model. So yeah, I just show that into here. Now, yeah, this is how we can use the MaaS, which stands for the model as a service. And another one I want to make sure is that multimodality here. So I use the Bing image creator to say, okay, draw the picture of Hanoi, Vietnam, and these generate those images. So I will choose anything. So I just click this image, then copy this image, and go to here, playground, use chat, and deployment model with GPT-4 vision. Then put here. So I will send this image and another prompt like create a day trip plan of the city in the image. So I don't say anything about the city, right? I just provide the image. Then what will happen? So this model, GPT-4 with vision, which supports multimodality, it will analyze this image and it will identify, the city of that image, and it will create the data plan for me. Let's do this. Okay. Hopefully it will recognize Hanoi. Yeah, it will generate. Oh, it takes time. Oh, yeah, something happened, right? Certainly. And Hoa Kiem Lake. Oh, yeah. So assuming the city is in the image is Hanoi, Vietnam. So like it correctly recognize the old city of Hanoi, and it provide me with data plan like morning, yeah, in the afternoon, lunch, and evening. Actually, some of places I have already visited during my trip, so which is really great. Yeah. So this is the capability of multimodality of using Azure AI Studio. Now, okay. So as I said before, so we talked about data security, okay? And at the same time, I want to make sure that how we can use these generative AI models, because in 2017, I think back in the day, we already as a Microsoft, we introduced an AI assistance model. But at the same time, I think just 2 days after, it just destroyed because of the abused that AI model. So after that, we started learning what need to be done before before publicly opening the AI models. So we declared these responsible AI principles. So which is fairness, reliability, safety, privacy and security, inclusiveness, transparency, and accountability. And with all Microsoft products and services, we have to pass these principles. Otherwise, we cannot release our products and services. So these principles are infused in our engineering processes that I mentioned before. So everything internally we build, we have to pass those tests, right? And otherwise, something will happen, right? So the same approach will be used for your product development, right? So one of those tools is Azure Content Safety, so which is a major addition of our safety products pipeline. So we use it internally for our Copilot, and we think it's good. So we are also offering for the public. So it is a thing that can identify things like hate speech or sexual content or something like the jailbreak attempt and so on. So this is our content safety, the product. Another tool was that evaluation that I showed you before, right? So that from this evaluation, we are making sure that our data set is properly indexed or properly demodeled so that we can use safely, right, within our product. So if you think of the servicing, the generative AI service for your customers, then it is really important to provide the data set, safe data set. Otherwise, they will get some, the inappropriate result. Okay. So let's talk about the full development life cycle. It's almost the end. So this is nowadays increasingly a key thing. So it's not just about calling the API and forget it. There's quite a bit of engineering effort that goes into the shaping the prompt, the model orchestration, and the APIs that are called, and so on. So you need to complete the way to do this. So we introduce, say, the prompt flow, right? So within AI Studio, we call it prompt flow, which is available for everyone to use. It is our tool for the prompt orchestration, evaluation, and prompt engineering. So it is deeply integrated with AI Studio. So and it's integrated with the machine learning, the Azure machine learning product as well. So something like that. So it gives us the complete tool chains to be able to understand the behavior of graphical models and APIs that we are calling. And also evaluate the outputs, right? And so these kind of things. So let's build our own copilot. But my Azure subscription doesn't support yet. So I took a video for that. So here is that there is a prompt flow, and choose the flow name here. And it shows when you go into the AI Studio, it has a bunch of flows at the right-hand side. And one is the embedding and the vector search and the formatting the outputs. And here is the input. And within the input, the system message, how can we format the system messages, and how can we set up those the variant as well. And here, this is the output format of answers, and which kind of document we are going to use, all the things. And once everything is done, we do the evaluation, right? So that evaluation is to make sure our prompt flow is correctly set up or not. So something like that. So we keep going and use the prompt flow, and using the chat node, and we choose which metrics we are going to use and which models we are going to use, and then click the next button, and then we will have the evaluation result. Based on that evaluation result, we will be able to see that the prompt engineering is correct, appropriate or not. So yes, click the submit button here. Then we will be able to see so those results, something like this. So if you go into the AI Studio, then you will be able to play something like this. Okay. Now, so that's the end of my talk. So if you are interested in how we can make use of a bunch of different use cases and share with the global community, then there is the QR code there, and there is Discord server. So it's Azure AI community. So go into the QR code, or visit this URL, aka.ms/Azure AI/Discord. Then you will be able to see or communicate with other the AI experts like you, right, from all over the world, right? So thanks for listening. So do you have any questions around the AI Studio, something like that? Okay. Oh,
You had plenty of questions.
oh okay.
So the first question is from Motivations Music. He asking, what are some common machine learning algorithms available in Azure AI Studio?
Machine learning algorithm.
Mhm.
That's a really good question. I have no idea. Because the purpose of using the large language model is that we don't have to worry about what kind of algorithm is running behind the scene, because that does everything for me. And what we can do, the OpenAI model, large language model, is basically we send a request and it generates an answer based on their learning. And that learning, the machine learning is already done by the OpenAI or like Beta or something like that. So we don't have to worry about those kind of algorithm.
Mr. Fee asking you when to use GPT 3.5 and when to use 4.
GPT 3.5 is cheaper, and faster, but less accurate. So that's kind of a trade-off. That's kind of a trade-off. So if you want to more accurate result, then use GPT-4, but it's expensive and it's a little bit slower. So think about the balance between the performance and cost optimization and accuracy, and that accuracy can be covered by RAG pattern as well. Yeah.
Another question is, what are the deployment options available for machine learning models in Azure AI Studio?
As I said, the machine learning model is the Azure AI Studio has the AI Studio is a collection of the AI service. The machine learning studio is a part of that. So I'm not going to cover this here, but there are a bunch of the machine learning models you can introduce. But besides machine learning model, currently we have definitely we have OpenAI models and Meta's Llama partnership and Cohere and what else, and Mistral or something like that. And that the more models keep coming up.
What are the best practice for retraining machine learning models in Azure AI Studio?
Question again? Say question. Can I ask a question again?
Yes, sure.
Yeah. What's the question again?
What are the best practice for retraining machine learning models in Azure AI Studio?
Retraining. Why? why you training? So here. So what are some best practices retraining machine learning models in Azure AI Studio? So the concept of using Azure AI Studio is that so if you want to use the training the models and use the machine learning studio, but I wouldn't recommend if to train the models from scratch, because there are a lot bunch of the existing models, the great models like GPT or Llama or whatsoever, right? So you can use that unless your business model is really training the models. Okay, so I think it's better to use existing models, and on top of those models, you can add your business values. I think that's much better and faster way to grow your business.
Could you please share about some best practice for securing data in Azure AI Studio?
That's a really good question. So data security can be done in three ways, right? So data in use, data in storage, and data in transmission. Those three things, right? And the data in store or data in storage can be easily done by like Azure Blob Storage or something like that, because it sits within your subscription. But in terms of data transmission, so for example, do we have the data center in Vietnam? Azure data? No. In that case, we have like we have to store our data outside Vietnam, right? In that case, and this is violates data in use and data in transmission, right? So just sending a data to another country is basically you're breaking the rule, right? So in that case, how can we make sure? So it's technically it's possible, but it's kind of the regulation issue. So in that case, probably your customer or your company should be kind of get an exemption or approval from your government agency, so that it shouldn't be breaking the rules, government regulation, right? So in Korea, actually, we do the similar stuff. So we do have data center in Korea, but the Azure OpenAI service is only open to the certain big companies like SK or something like that. They use their own data center in Korea, but other than those companies, other than companies other than these big companies, they have to send their data to outside. The closest place is Japan, right? But as I said, this is like I'm crossing the border in this case. Even if we are like we are encrypting all the data, is to encrypting all the data to send the across the border, then unless the data is anonymized and it is violating the rule. So the solution to secure your data is to anonymize your data set. So you need to anonymize all the personal information stuff, right? So like the hashing all the names and like security numbers or something like that. So these kind of things all should be all anonymized. Then you can send the data in a secure way, like through a private link or something like that. Otherwise, those kind of personal data cannot be go overseas unless you have exemption from your government. I think that's it.
Yeah, because he asking the same question is his client asking him about compliance GDPR of using Azure AI Studio. He wants to ask you if you can give him some advice for that.
Oh, that's I cannot give an answer because that's too comprehensive. So I have no, and so I only have very small the knowledge of that. So I don't think I can cover their question.
Any question here?
Yep.
It's not related to Azure AI. What do you think the future of software developer with AI?
The question is about the future of software development using AI. We are at risk, you know. So we need to be careful for our losing our job. No, no, joking. You know do you use GitHub Copilot? Yeah. So I think I'm there every time. I cannot imagine without GitHub Copilot anymore. But you know, at the same time, GitHub Copilot suggested me with the code generation, but it doesn't say it's always correct, right? We have to review our code, right? So I think if you are a senior developer and if you understand the business domain, then it should be fine from my perspective, because the Copilot or AI can generate the code for me, but that's not reflecting our knowledge of domain business, right? But if you are a junior developer, then I think you should be very careful and you should be ready for competing to the AI agent. And recently there is another AI programmer. What is Devin? Devin AI. Yeah, that actually is very interesting. Devin AI schemes all the GitHub issues, and it actually submitted all the PR and accepted the PRs, right? And say 19% of PR was accepted, which is great, right? But at the same time, we can assume that 81% of PR is not accepted yet, which is because that Devin AI doesn't understand the business domain yet, right? So all you need to do is that you should be an expert of domain or business, right? Business itself. Otherwise, you will have to compete your AI, right? So keep going. Another question? Oh, yeah.
I believe that's some organization or company. I believe that some organization or company has. I'm sorry, I don't know how to use. So my question is, if we want to have the AI to as an assistant to respond the question of the customer of the business, should we can we use Azure AI Studio to train something like that to have the better chatbot to fit with the business of the organization.
Yeah, that's that's what I showed you as a RAG pattern, right? So your question is that can we use the Azure AI Studio? I mean the Azure OpenAI model to help or to grow your customers' business, right? So that's I understand that's the question. So as I said, the Azure OpenAI is a foundation model, and we don't train foundation model. And it returns the answer in a very generic way. Like tell me about the city of Hanoi. Tell me about BTS. Tell me about Blackpink. Right? This kind of thing, it answers like a very good way, kind of that. But let's say your customer is selling some sort of legal service or something like that. Then it doesn't understand, and you have to feed those foundation model with those specific data, like the Vietnamese like commercial law or something like that. Then once it is fed with those data as a RAG pattern, then it will be able to answer something the correct way. So then your customer's business will grow up on top of the foundation model. That's how we do. Right? Did that answer your question? Yeah.
So, can you have you ever tried with bigger data shots? Because with the demos quite small data shots. I want to ask you about
Yeah. So your question is about I have an experience about using the large set of data. Yes. Because it's a demo, so I used a small data set, and personally my experience that about I used all the law data. I mean, from the Korean, the government law, so about like a commercial law or like the housing law whatsoever. I put everything into the as a RAG pattern, and I asked a question, and it actually the answered quite well. So yeah, that's my personal experience. So I think yeah, based on my limited experience, I can say as long as we put the right data set, and we can get the good result. And if you have a big amount of data, and that's also fine, I think, because we are not directly using the data itself. We push the data into our the blob storage or any data storage, and it indexes and in the vector. Then and the vector is basically the set of the digits. So yeah.
I have a question. So we know that after the one of the last model, so there are several maybe listed in the top 10 or not on LLMs. So my question is, do we have the plan to support that feature in the Azure AI Studio?
Yeah, I think we within our where is model catalog? Yeah, within our model catalog here. So there is, where is it? Model benchmark. Where is it? Where is it? Hang on. So benchmark here. There is the Microsoft Pi 2 here. So we have already have bunch of the large language model and the small language model as a part of catalog. And I don't think that's all. So we keep coming in. So if there are new models coming in, then we will be able to add these models into our model catalog. And based on the model catalog, then you will be able to choose which model is good for your specific business needs. Yeah, is it? Okay.
Suppose I use Azure OpenAI CBT 2.5 for my foundational model in a chatbot solution. But there is an issue with is that something like say from injection attack. So how I can prevent that from my application?
Oh, that's a really good question. So that's one of our prompt engineering effort. So as I at almost end of my talk, we talked about responsible AI, right? And responsible AI and takes care of those kind of jailbreak attack, prompt injection or something like that. So we do have our own the foundation model to prevent those kind of attacks. It's comparing to like the OpenAI's ChatGPT. They have their own protection model, I think, and we have our own protection model. So these kind of things you don't have to worry about those kind of jailbreak attack because we have our own content safety the policy as well. So based and that kind of things you can dissolve into our prompt flow. So within the prompt flow, you add those embedding data and content safety the policies in there, then and the change some prompt flow, then you will be able to see, oh, this way we can protect our data, and that way, oh, that's not protecting our data. You can find out these are correct prompt flow or not. They're based on these are all your prompt engineering attempts. So yeah, you can build the prompt flow for your the business needs.
Yeah, so I understand that we can add our custom flow
That's right.
to the entire flow.
Yeah.
Let's say that's the flow for prompt tabulation. So in that activity, I can use any existing model or my custom model for detecting the from injection attack. Yeah. And plug it into the whole flows in the Azure AI Studio.
Yep, that's how we do in the prompt flow in here. So prompt flow here. So these based on that you can choose whatever you want. And so I showed you is that there is a prompt here and the prompt which kind of large language model you can add and which kind of prompt you can add as well. And those another like Python scripts you can add as a function calling. Something like that. So all those things that you can orchestrate together. So by doing so, yeah, if you have a good like the prompt injection attack, the prevention tool, then you will be able to add these that tool into your prompt flow, so that your customer will be able to use without worrying.
Yeah. Cool. Yeah.
Thank you. Any other questions?
Yes. Is Azure friendly to hobbyists or is it only reserved for enterprise?
Is Azure friendly to hobbyists or is it only reserved for enterprise? That's a really good question. So Azure OpenAI is currently open for the companies and organizations, not for the personal use. So if you want to use the Azure OpenAI for your personal use, yeah, I don't think it's a good idea. I mean, I don't think you can use directly within Azure subscription unless you are within the company or organization.
Can the user can I integrate the AI into an existing database so that I can query by human language?
Oh, yes, you can. So existing data set like Azure SQL database or PostgreSQL database or any MySQL database or MariaDB whatsoever. Yeah, you can use the existing data set as a the data source, right? And you can based on that data set, you can train your you can train your like you can how can I say, you can index it and for your RAG pattern.
Could
and
you please?
yeah, there is the last year I had hackathon event. I hosted the hackathon event, and actually they use their own the data set, and like they just send the human language. I want to have this and this, and then it automatically convert into the SQL data query and returns the right data set.
Another last question is, could you please share more about integrating Azure AI Studio with Azure services? I assume that is very easy, right?
Yes.
Any limitations we should know?
Oh, the limitation is the sky. No, I'm joking. So the Azure AI Studio is so all we need to do is that provide the right data set from the various different data sources, such as like a blob storage, or like a SQL database, or other any sort of database, and or like a Cosmos DB or something like that, right? So it's very easy for integration, and even you can use your existing the Azure service product and services on top of Azure AI Studio, right? So for example, I'm personally like I'm building a kind of demo with the Azure OpenAI service with like an API management or Azure Service Bus or something like that. So to integrate everything as a data source or application development. So yeah, it's very easy as long as you are within the Azure.
So yeah, that's the last question for you.
Thank you for listening, and I will hand over to my colleague Richa, and she is talking about Azure Cosmos DB, right? Yeah.
Can you download the file for us?
Hey everyone, how are you doing? Good? Yeah. So much energy, so many questions. So let me give a quick introduction about myself. I am Richa Gaur. I am based out of India, Bangalore, and I am a product manager at Azure Cosmos DB team in Microsoft. And today I'll guide you through a.
You have a camera here. You should have a look because they are online in Ho Chi Minh City as well.
Oh, okay. Okay, thanks for mentioning that. Yeah. So today what I'll do is I'll guide you through a developer's journey from onboarding to production on a NoSQL database using Cosmos DB. So before I move further, I just wanted to get a check on the audience. How many of you are developers here? All? Yeah, that's pretty good. And how many of you have used a NoSQL database? Almost. Which one? MongoDB? Okay, then probably that makes my job easy because you'll be quite familiar with a lot of concepts that I might talk about today. Okay. So today's session will be covered in three parts. First is setting up the Cosmos DB in right way. We'll cover data modeling, setting up the partition key, and estimating capacity for our containers in Cosmos DB. Then we'll move to the development of application. That's your client side. We'll talk about some of the optimizations that you can do using the SDKs that we provide in Cosmos DB. And finally, before moving to production, what things you need to keep in mind in order for high availability and monitoring and logging for your application. Okay. So just to give you a quick introduction about Azure Cosmos DB. It's a fully managed database service, NoSQL database service by Azure. What that means is that you don't need to really worry about the deployment or maintenance of the database. All the infrastructure is taken care by us for you. All you need to do is use it using the SDKs or the client libraries that we provide. It is multi-API, multi-model. What that means is that we offer the core NoSQL API where The data is stored in JSON format, similar to MongoDB, and you can still query using SQL-like language. The dialect is still SQL. You can still do select star from database where filter equals to ABC. So it's so you get best of the both worlds in this scenario. And we also have compatibility with the interop APIs that are open source, like MongoDB, Cassandra, Gremlin, as well as Postgres. So if you're familiar with MongoDB or Cassandra for that matter, you can continue using your client library, client applications as it is, and you can move the data to Cosmos DB. So that frees you up from the maintenance of the database, as well as gives you the goodness of the open source community. It is turnkey globally distributed. What that means is that you can make your data available in any in the globe, in any Azure region, just by one click. The replication is fully taken care by us. And finally, it is a very highly available, highly performant database, which is covered by comprehensive SLAs from our side. So just to make this talk a little simple, we'll take a real world example of a logistics application called Contoso Logistics. Uh, uh, this application, the architecture could simply look like this. So we'll talk about two scenarios. First is the write heavy scenario. Here, what we'll do is we will ingest IoT data from our vehicles in the fleet at a very high rate. And the second is the read heavy scenario, where we are what we want to do is we want to monitor the real time status of our vehicles, consignments, packages in the fleet, so that we can monitor them in case any issue arises. So that requires reading the data from the database at a very high rate as well. So as you can see, there are multiple components in this architecture, but for this talk, we'll just focus on the Cosmos DB. So before I move on to explain the core concepts, I just wanted to let you know what are the use cases when you should consider using Cosmos DB or NoSQL database for that matter. First is schema flexibility. So in our scenario, we are dealing with the sensor data, which can change over time. Today, we may receive 8 fields. Tomorrow, it could be 7 fields or even 10 fields. And we don't want to deal with the pain of schema migration when that happens. Have any of you dealt with schema migration before? Yes? It is painful or not? Okay. So yeah, having JSON as a document format gives you that schema flexibility. Second is scalability. We are dealing with very high rate of writes, and Cosmos guarantees throughput for any workload, no matter how small or how large that is. So our writes are taken care of. We want our application to be fast. We want real-time updates. For that, the application needs to be very, very fast. And Cosmos DB guarantees read and write latency of less than 10 milliseconds at P99 for a document of 1 KB. That means that for if you're doing 100 writes, out of 199 will complete within 10 milliseconds, which is pretty fast, right? And finally, high availability. We don't want our application to go down so that we don't lose the status of any vehicle in our fleet. With Cosmos DB, with 2+ regions, you can get 5 nines of availability by default. So seems like Cosmos DB is a pretty good fit for our use case, at least for this application. So let's move on to setting up the Cosmos DB account. I don't have the demo right now, so I'm just using the slides to just showcase how does it look like. So this is a screenshot of the Azure portal where you create the Cosmos DB account. As I mentioned, it is multi-API. So you can choose any of the API which makes more sense for you or which is more fit for your use case. For this, we are going to use the core NoSQL API. So in order to create a container, you just need to provide the account name, the region in which you want to create the account, the capacity modes, whether you want a serverless account or a provisioned throughput account. What exactly that means is I'll talk about it later. And that's all. That's how you create a Cosmos DB account, just 3 steps. And this is what a resource model looks like in Cosmos DB. The top level entity is the account. And then we have databases like Contoso Logistics in this case. And within databases, we have different containers. Think of containers as table in relational world. So it's pretty similar to table. And the data is stored in JSON format, as you can see here. Finally, moving on to creating a container. So while to create a container, you need to give the database name, then the container name, and partition key. This is something new, right? Okay. And we have to, there are some number 4,000 I can see on the screen. So this is capacity that you need to provide in order to provision the container. So that's how you create a container. Talking about capacity, so for any NoSQL database, you need to provision certain capacity in some form or the other. For MongoDB, you might, provision nodes like vCore or something, right? You have to provide how many vCores you want in the cluster or those kind of things. So request units is what you need to specify when you are specifying the capacity in Cosmos DB. Request unit is nothing but an abstraction of the resources that are required to execute a request, like memory, IOPS, CPU, etc. So it is just a currency that we use so that you can think in terms of just one thing instead of thinking about multiple things. That makes it easier for you to provision the capacity. Capacity can be provisioned both at the database level as well as the container level. This means that you can have dedicated capacity for a container, or you can share the capacity between multiple containers by setting it at database level. So let's just quickly see how you can estimate the capacity for the application that we are going to build. This is what a sample telemetry event document looks like. It's a JSON document of 15 properties or so. I'm not sure if you can see the screen. So the font is a little bit small, pardon for that. So what I'm doing, so this is a snippet of my IntelliJ IDE. Here the code is written in Java using Cosmos V4 Java SDK. I'm using Java because I'm familiar with Java, but you might be familiar with Python, JavaScript, or anything else for that matter. So we have SDK in all the languages like Java, Python, Node.js, Golang, and as well as .NET. So whatever language you are familiar with, you can use the SDK of that language. So here what I'm doing, it's pretty simple. I'm writing a document into the container and reading the request charge from the response. Can you see this? Similarly, I'm reading the same document and finding the request charge for the read operation as well. And when I run this code, this is what the output that I get. So I can see that to write the document, it takes 10 RUs, while to read, it takes just 1 RU. So with that information, let's try to estimate the capacity that we need for our container. So assuming that we have 1,000 vehicles in our fleet and each vehicle sends one request, one write request every second, that means we need 1,000 writes per second, right? And each write requires approximately RUs. That means we need 10,000 RUs per second for our container. So this is the capacity that we need to configure. The box that we had in which 4,000 written, we need to enter 10,000 RUs so that we can have appropriate capacity in the container so that our 1,000 requests can be successfully executed. Does that make sense? Seems quite complicated. Okay. So we also have a capacity calculator, which is just a fancy UI on top of all these calculations that I just did. So you can use probably a capacity calculator to do the same thing. It tells you the request units that you need, and also the associated price based on the provisioning model. Talking of provisioning models, there are different models in which you can provision capacity in the Cosmos DB container. From like what I showed, it took a little bit time for you to understand how to estimate capacity. So if you really don't want to deal with the capacity estimation at this point, like when you are starting out your application development, or when you might not have clear understanding of how much workload your how much traffic your application is going to get, so what you can do is you can provision a serverless account. When we were creating the account, we had to choose the capacity type, right? Provision versus serverless. So you can probably choose serverless account, which where you don't need to provision any capacity at all and don't deal not deal with the capacity estimation. It's based on consumption based pricing model. So you actually pay for the requests that are coming to the container and don't pay anything otherwise. So it's just based on your usage and nothing else. So it's quite good for customers who are starting out on Cosmos DB, or who are testing their workloads, or who have very infrequent access to the database, so that it remains pretty much idle all the time. So yes, you all you need to do is choose capacity mode as serverless. Moving to provision throughput, we have two models in provision throughput. First is autoscale. Autoscale is basically good for bursty, unpredictable workload pattern. So what you have to do is you have to provide a maximum capacity that you could use, and your container will scale from 10% to max of that capacity instantaneously. So let's say your workload patterns look like this in the day, and you don't know how much traffic like at what time what kind of traffic comes. So you are quite unsure about your traffic needs, so you can provision for a certain maximum capacity, and your container will scale between 10 to 100% of that capacity instantaneously. So for example, if you're using only for 40% capacity, you need to pay for only 40%. You really don't need to pay for 100%. Or sometimes when spike comes, your container will scale to 100% instantaneously to absorb the spike as well. So it's quite good for these kind of workloads where the traffic pattern is truly unpredictable. Finally, we have manual provisioning mode, where you provision a fixed capacity which is payable and available at all times. So it's pretty good and cost friendly for the workloads which have a steady traffic patterns. So yeah, that's how you can choose any provisioning model that is suitable for your application on Cosmos DB. Moving on to partitioning. Do you remember that we had to provide a partition key when we were creating a container? Can anyone guess why? Yes, exactly. To do the sharding. So partitioning is basically the key to scaling. That's how you distribute the data in a distributed system, in a distributed database. It's the key to horizontal scaling. So Cosmos DB uses multiple machine to distribute the data based on the partition key, and instead of just using one large machine to do the vertical scaling. Think of it as working in a team where you have multiple team members. So so the workload is generally equally divided between all team members. So this is exactly how partitioning works in Cosmos DB. So this is what the data distribution looks like. When you define a partition key, that is called logical partition key, and the data between the same logical and data for same logical partition key will always go to the same logical as well as physical partition. So that's how basically the scaling works in Cosmos DB. As and when you ingest more and more data, new and new partitions are created, and data for same logical partition will always go to the same physical partition. So it becomes paramount that you choose a partition key which distributes the data equally among all nodes, and also the request volume, right? So the general best practice from our side is that for write-heavy workload, you should choose a high cardinality of partition key so that you have lots of partition keys, so that your data is accessed and written to different physical partitions concurrently, and you can benefit from all the throughput available to all the partitions. And for read heavy workloads, you should always do a key value lookup by supplying the ID and partition key so that the exact document is fetched from the container. By the way, the key value lookup always takes 1 RU, as we saw in the demo earlier. And finally, for queries, you need to make sure that you always supply the partition key, as you might have done for the might have done with the sharding key in MongoDB, right? So you need to supply the partition key so that your queries are directed to one single physical partition instead of fanning out to different physical partitions. So that will also consume more resources as well as take more time in executing the queries. Let's just see a simple demo of how this makes a difference in the performance of our application. So I have one container v1 where the partition key is ID. Then I have another container v2 where the partition key is username. The data and the amount of data is exactly the same in both of these containers. The only difference is the partition key. So what I want to do is I want to query a particular username. I want to query the documents of a particular username. So I'm doing a query called select star from C, where username equals to, let's say, ABC. Now, when I execute this query against v1, it consumes 82 RUs. While when I execute this query against v2, where the partition key is username, and since we are using username in the filter, so what is happening is it is just going into one single physical partition. Sorry. And that's why it consumes less RUs. So here the difference is only 20 RUs, but as your data grows, this difference can become huge. So it is advisable that you always always choose a partition key which covers the maximum use cases of your application queries. Now that we have understood the basic core concepts of Cosmos DB, let's move on to developing the application. So here I'll just talk about some of the optimizations that you can do from client side in order to make sure that your application is performant. So first is running point reads. I think I talked about it earlier as well. So point read is a API, this container.read item, where you supply the ID and partition key of the document. So this is for key value lookup. So whenever you have to do a key value lookup to read an item, you should always use point read API instead of doing the query. Point read will always consume 1 RU, while query can consume any RUs depending on the complexity of the query and like the size of the data in the container. So here you can see it not only consumed more RUs, it also took more time. So it is advisable that you always use the point reads. Although we are saying that you should always supply the partition key filter in the queries, but sometimes we have queries where we need to run cross partition as well. So in those scenario, you should let the SDK take advantage of the parallelism that your client can offer with the configuration it is running. So there is a configuration called max degree of parallelism, which controls the concurrency with which the queries can run. So what happens is when you set it to -1, the SDK will optimize the number of threads it needs to run to parallelly query different physical partitions, so that what it does is it queries parallelly the data from different physical partitions, and it does it in a very optimized fashion so that your client is not burdened with the resources, as well as it takes the maximum concurrency benefit as much as possible. So when I'm running it with -1, I can see it took certain time, but when I'm running it with a finite degree of parallelism, it takes more time. So it could happen both ways. Either you can, choose lesser number of threads, which limits the concurrency benefits, or you can choose more threads as well, which can, burden the client side resources and cause your application to choke or even, get thrashed. So you should always consider using degree of parallelism to -1, so that you are not burdened with the complicacy of parallelism or concurrency at all. You should let SDK take care of that by default. Moving to indexing policies. So we have understood that we need to use point reads. We need to make sure that our queries are single partition, or if we're using cross partition query, we should take care of concurrency. But what about writes? So in Cosmos DB, indexes the indexes are created by default for you. So this is what a default indexing policy looks like. So by default, all the fields within the JSON document are indexed. So while this gives you convenience that whenever you are, adding a new field in the JSON document, that is indexed by default. You don't have to think about indexing the new field as you might need to think about in a relational document, not document, sorry, in a relational data model. So while that is an advantage, it becomes a burden when you write the documents, because when you're writing, you also need to update all the indexes that are there in the that are there in the data in the container. So what you can do is you can tune your indexing policy. So you can, just include those fields which are actually required in your application queries and exclude rest of the fields. This will also give you the right indexes, as well as optimize your writes to not, write extra indexes which are not anyways required. So just to give you a simple example, when I write this telemetry document with the default indexing policy container, it takes around 14 RUs. And when I write the same document using a tuned indexing policy, it takes only 7 RUs, which is just half in this scenario. So with this simple optimization, you can reduce your capacity to just half. So whenever you are whenever you're configuring a container, always think about indexes so that your writes are always optimized. Moving to monitoring the application performance, Cosmos DB provides some default metrics that are accessible to customers using Azure portal. So we have metrics related to request, like total request, bifurcated by status code, operation code, resource types, etc. And then we have metrics related to throughput, where you can get information about how much resources are consumed by different requests. That are again, bifurcated. You can also bifurcate them with the status code or operation type or even container name, database name, anything for that matter. We also have metrics related to storage, availability, latency, etc. And all of these metrics, while are available in Azure portal, they are also available via the APIs in the SDKs. So you can build your own dashboards apart from these, and also custom alerts on top of that. All of the metrics that I'm showing here are aggregated metrics. These are aggregated on 1 minute or 5 minute level. We also have per request level metrics that you can enable on your account using log analytics. Now that we have covered everything, we have set up the Cosmos DB, we have understood the concepts, we have developed the application using the SDK. Now it's time that we hit the production. But before hitting the production, we need to ensure that our application is highly available. So what we can do from our side to make the application available, highly available, is add a second region in Cosmos DB to achieve 5 nines of availability. By the way, anyone here knows what 5 nines of availability means? How much downtime in a year it is? Any guesses? How many hours or minute it might be? So per year. Any wild guesses? Okay, no worries. It's 5 minutes and 26 seconds of downtime in a year. So with one region, you get 4 nines of availability in Cosmos DB by default, which is 52 minutes of downtime in worst case scenarios. And with 5 nines, you only you get 5 minutes of downtime in a year, which is pretty good, right? So all you need to do is just add a second region by going to Azure portal, choose any of the region in the globe and add that region for high availability in Cosmos DB. So just to summarize, what you need to do to make your application a success with Cosmos DB is you need to set up the Cosmos DB right way by choosing the right API, modeling the data for your application queries, and then accordingly choosing the partition key which covers maximum of the query scenarios, estimating the capacity. Then while you're doing the development, take care of all the knobs that are there in this SDKs to so that your client side performance is good enough. Then while testing, you can use local emulator as well, which is just a desktop client application that you can download on any of your operating system and test locally as well. It is just as same as using a cloud using the cloud service. You get the same RUs, same response, everything is same. It's just on your machine. So for Linux is a Docker based application. And finally, before hitting the production, make sure that your database service is working properly with the metrics that are there. Make sure that the performance is as you expect, and add a second region for your high availability requirements. That's all from my side. Thank you.
You have first question online is what are the different consistency levels in Azure Cosmos DB and how do they impact performance?
Yeah, that's a very good question. Just
Let me open that.
So yeah, that's a very good question. There are 5 levels of consistency that Cosmos DB provide. You would have like how many consistency level you know? Everyone would know asset transactions, right? Yes or no? So that's strong consistency. Like when you do a financial transaction, it is a strong consistency model that is guaranteed with asset transactions. In relational models, we have asset transaction, atomicity, consistency, isolation, and durability. So with asset, what a relational DBs provide, that strong consistency. So we have strong consistency. And then we have the weakest form of consistency, which is eventual consistency, which most of the NoSQL databases provide. So within these two extreme parameters, we have three consistency levels as well. Beyond the next level from strong to next below level from strong to is bounded staleness. So strong guarantees that your data is consistent in all the regions. With bounded staleness, you can specify like what bound, like in terms of the number of copies, number of versions, or the time, whichever is earlier, how much stale data you want to see. So that's bounded staleness. Third is session consistency, which says that you read your own writes. So when you use the SDK to make a query or do any operation on the database, that forms a session. So session consistency says that when if you write anything within the same session, you can always read the data. So you can always read your own writes. That's session consistency, and it is also the default consistency that we provide to the customers from our side. So that's pretty good for single region scenarios. Then we have consistent prefix, which is again there is the latency of k prefixes that you can provide uh, by with how much your the updates would be delayed. Then finally we have eventual consistency, then that says that your data will be eventually consistent between different replicas of the data. Does that answer your question?
Any question in the hall? Justin, do you have any question for her? think it's
Okay.
good for now.
Okay, thank you so much. We also have a Cosmos DB Conf upcoming, which is on 16th of April. It is fully virtual and free. So you can, register for the conference and, dive into specific topics that you want to learn about Cosmos DB. It's free, so you can view it on YouTube, either live or on demand. Thank you. And finally, we have I think someone asked about the free Azure AI service or for something for developer on Azure. For Cosmos DB, we have a completely free tier for students and hobbies developer, which is free for lifetime. It just has a data size limit, which is good enough for a lot of use cases that developers want to try out. So just I have a link, but this link is somehow not working. So you can probably go and find out free tier Cosmos DB online and just create an account. It is completely free for your lifetime, and experiment with it. We have so many GitHub applications. You can download any one GitHub application in any of your language choice and try experimenting with it. Thank you so much.
So that's come to the end. So thank you everyone from Hanoi and Ho Chi Minh City that joined the virtual live event today. Hopefully that we will have another session in Ho Chi Minh City, right? Session. Yeah. So thank you, yeah.